Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we'll start exercise exercise 11.1. Exercise 11.1 of surface area and volumes, class 10th. Surface area and volumes, exercise 11.1, class 10th. Let us have question number 1. Question number 1 says, two cubes each of volume 64 cubic centimeter are joined end to end. Find the surface area of the resulting cuboid. It says we have two cubes which are joined end to end. Let me draw a figure. It's like this. These are two cubes which are joined end to end. Just like this. Like this. Two cubes are joined end to end. Volume 64 cubic centimeter each. The volume of this cube is 64 cubic centimeter. So as here, 64 cubic centimeter. Find the surface area of the resulting cuboid. Now you need to find now when you join cube and cube, you'll get a cuboid. When you join two similar cubes, you'll get a cuboid. So now you need to find the surface area of this resulting cuboid. See. First of all, we can do one thing. First of all, I write here volume of cube. Volume of cube is equal to 64 cubic centimeter. 64 cubic centimeter is the volume of cube, which implies that I know the formula for finding out volume of cube. You can refer to the introduction part of the lecture. So volume of cube is L cube is equal to 64, which implies that L cube is equal to 4 cube. Therefore, L is equal to 4 centimeter. Now this is your length of the cube, 4 centimeter. Similarly, the volume of this cube is 64 cubic centimeter. So again here you have 4 centimeter length. Now the total length of the cuboid will be 8 centimeter. 4 plus 4. It is simple. And this is again the length of the cube, that is 4 centimeter. And this is the height of the cube, that will be again 4 centimeter, because you know cube has length, breadth, height equal. Now total surface area of cuboid, it is equal to twice LB plus BH plus HL. That is equal to twice LB plus BH plus HL, and that is equal to twice length is 8 times breadth 4 plus 4 times height 4 plus height 4 times length is 8. Now solve it, you'll get 32 plus 16 plus 32, and that will give you 2 times this is 30 plus 30 is 60, 70, 76, 80, 80, and that is 160, and it is surface area. You know surface area is in square units, so 160 our units was centimeter, so it's square centimeter. Hence the required total surface area, hence the required surface area of the resulting cuboid is 160 square centimeter, and that's your answer. Make a note. Now let's have the next question. Question number 2. It says a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 cm and the total height of the vessel is 13 cm. Find the inner surface area of the vessel. Now, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. You have a vessel which is in the form of a hemisphere, just like this, mounted by a cylinder. Just like this. It's like this. Vessel is the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 cm. Diameter of the hemisphere, so this thing is 14 cm. Then, and the total height of the vessel is 13 cm. Total height of the vessel is 13 cm. 13 cm. Find the inner surface area of the vessel. Now you need to find the inner surface area of the vessel. That means you have to deal with the curved surface area of the vessel. So it goes like this here. Diameter of base. Now this diameter of base is equal to diameter of hemisphere is equal to diameter of cylinder. And that is equal to 14 cm. Which implies that radius of base is equal to radius of hemisphere is equal to radius of cylinder. And that will be 14 divided by 2, and that is 7 cm. Diameter, radius. Then the total height. Total height of a vessel. Total height of vessel is 13 cm, which implies that then I can find height of cylinder. Height of cylinder will be equal to, now you know one thing, the radius of hemisphere, remember this, radius of hemisphere is always equal to height of hemisphere. Remember this point. Radius of hemisphere is equal to the height of hemisphere. Radius, because this is radius, this is radius, this is radius, this is radius, and this will be your height. So radius of hemisphere is equal to height of hemisphere. So height of cylinder is equal to total height of vessel minus height of hemisphere. So the height of hemisphere is radius of hemisphere. That means height of cylinder is 13 minus radius of hemisphere. That is 7. Minus 7, and that is 6 cm. So height of cylinder is 6 cm. Therefore, what we need to find is inner surface area of the vessel. Therefore, inner surface area of vessel is equal to lateral surface area or curved surface area curved surface area of cylinder plus curved surface area, because it's open by the top. Curved surface area of cylinder plus curved surface area of hemisphere. Now curved surface area of cylinder, you know the formula, it's twice pi r h, plus curved surface area of hemisphere is twice pi r square. Now this radius is same, so I can take twice pi r common. I'll get h plus r, and in that case gives pi is equal to 22 by 7. So I have 2 times 22 by 7 times radius is 7, then times h is height is of cylinder, that is 6, plus radius is 7. Then I can cancel 7 and 7, that is 44, cancel 7 and 7, 44 times 13. So now multiply 44 and 13. It's 572. Now its surface area is in square units, so square centimeter, and that's your answer. Make a note. Let's have question number next. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere. Toy is in the shape of a cone mounted on a hemisphere. So let us draw a diagram for it. Toy is in the shape of a cone just like this. Cone mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. The total height is 15.5 centimeter. This is the total height of the toy. Height of cylinder, cone plus height of hemisphere. Find the total surface area of the toy. You need to find the total surface area of the toy. Radius is 3.5 centimeter. Radius is 3.5 centimeter. So you need to find the total surface area of the toy. It goes like this. Here, radius of cone is equal to radius of hemisphere is equal to 3.5 centimeter. Radius of cone is equal to radius of hemisphere is equal to 3.5 centimeter. Then total height of toy, and that is equal to 15.5 centimeter, which implies that height of cone Let us find the height of cone. Height of cone is equal to, height of cone is 15.5 minus 3.5, because I just told you that height of the hemisphere is equal to the radius of hemisphere, and that is equal to how much? That is 12 centimeter. Therefore, total surface area of, is it total surface area? Yes, you need to find the total surface area. Total surface area of toy is equal to, now total surface area of toy is curved surface area of cone plus curved surface area of hemisphere, because this circular portion is not included in the total surface area of the toy. For example, this, imagine this formation of toy. You have cone, you have hemisphere mounted by a cone. Now if you want to, for example, paint this toy, when you paint the toy, you just paint outside like this. You will not consider this circular portion because it's inside the toy. So you will consider the curved surface area only of both the figures. So total surface area of toy is equal to curved surface area of cone plus curved surface area of hemisphere. Like this. Now you know the formula for curved surface area of cone, it's pi r l, yes, plus, now curved surface area of hemisphere, that is twice pi r square. Now radius is same, so you can take pi r common, which will get you l plus 2r. Am I right? 2 pi r square, yes. Then you get pi r times l, you know it's h square plus r square. This is the formula for slant height of the cone. You can refer to the introduction part for this. L is equal to square root h square plus r square plus 2r. Now put the values. This is 22 by 7 times r is 3.5, then times h is what about h, 12 square plus 3.5 square under the radical, then plus 2 times 3.5. So it's like this. Now you can solve this. How you can solve this? You can first square this, so it's 144, then plus 3.5 times 3.5, it's 12.25. 12.25 plus 144, 144 plus 12.25, that will give you 156.25. Then get the root of 156.25. Get the root of 1. First of all, square this, so you'll get 144. Square this, add them, then have the root of that, add 3.5 times 2, that is 7, add 7 to it, then multiply this whole thing with 3.5, then multiply 22, then whole divided by 7. You got it? And that will give you 214.5 square centimeter. Square centimeter, and that's your answer. Kindly make a note. Now let's have question number next. Question number 4. Question number 4 says a cubical block of side 7 cm is surmounted by a hemisphere. Cubical block, now this time we have a cubical block surmounted by a hemisphere. So it will be like this. Let me make it. We have a cubical block this is a cubical block, this is surmounted by a hemisphere. So let me go like this. It's like this. Just like this. A cubical block of side 7 cm is surmounted by a hemisphere. So this has 7 cm side. Yes, cubical block of side 7 cm. So this is 7 cm. Got it? Is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? What is the greatest diameter a hemisphere can have? Yes, it's 7 centimeter, because this is the diameter of the here the greatest diameter that a hemisphere can have is 7 centimeters. Then it says find the surface area of the solid. You need to find the total surface area of this solid cube surmounted by a hemisphere. Now if you want to paint this whole thing, will you include this circular portion of the cone? No, because it will not be visible. This circular part of the hemisphere, this will not, base of the hemisphere, this will not be visible, because a cone is surmounted on the a hemisphere is surmounted on the cubical block. So that circular part is not visible at all. Therefore we can say like this: total surface area of block, it is equal to total surface area of cube. Now when I say total surface area of cube, so I am including that circular part as well, because the top of the upper side of the cube includes that circular part of the hemisphere. When I say total surface area of cube, but I need not to consider that circular part, so I say total surface area of cube minus area of circle, then plus curved surface area of hemisphere. Curved surface area of hemisphere. Again, not total surface area of hemisphere, because I am not considering the circular base of the hemisphere. So this will be my formula. Total surface area of cube, you know, it's 6 times length square, minus area of circle, it's pi r square, plus curved surface area of hemisphere, it's twice pi r square. Then I go 6 L square, then this is plus pi r square. 2 pi r square minus pi r square is pi r square. Now for this, you get the value 6 times, now length is 7, so 7 square plus 22 by 7 times radius is half of diameter. If diameter is 7 centimeter, then radius is 7 by 2. 7 by 2, then square. So you can solve this. First you can square this, then you can multiply this with this thing, multiply this individually, then add the results, and you'll get 332.5 square centimeter. 332.5 square centimeter, and that's your answer. You got it? Let me show you here. Okay. Question number 5. Question number 5 says a hemispherical depression is cut out from one face of the cubical wooden block. This time, what you are going to do? You have a cubical block. Now hemispherical depression is cut out from this cubical block. So it's like this. This time it's like this. Now cubical hemispherical depression is cut out from this cubical block. Cubical wooden block such that the diameter L of the hemisphere, diameter L of the hemisphere. So this is your diameter and this is L. Diameter L of the hemisphere is equal to the length of the cube. So this is L as well. Determine the surface area of the remaining solid. Now, again, here, total surface area of solid is equal to total surface area of cube. Now again, imagine a situation. This is a cubical block. Hemispherical depression is cut out. This is a solid cubical block. Now if you want to paint this, so you'll paint these 5 sides of the cube and the bottom, 4 sides and the bottom. Plus you will add the curved surface area of the hemisphere. Plus you will add these portions, these sectors of the top side. So that means, in other words, I am saying total surface area of cube. Now from total surface area of cube, I need to subtract the area of circle, this thing, because it's open by the top. So subtract area of circle. Then I am going to add lateral surface area or the curved surface area of hemisphere. Got it? Same as above. Because in both the cases, you are adding curved surface area of hemisphere. Here, you are painting the curved surface area of hemisphere. Here, also you are painting the curved surface area of the hemisphere. Now total surface area of cube, it's equal to 6L square. Now minus pi r square plus curved surface area of hemisphere is 2 pi r square. Then you go 6L square plus pi r square. Then what you're going to do, put the values. L is L plus pi, keep pi as such. Now r, what's r? Diameter of the hemisphere is L, that means the radius of hemisphere would be L by 2. So it's L by 2 whole square. That will give you 6L square plus pi L square by 4. That will in turn give you 24L square plus pi L square divided by 4, and that will give you take L square common, then pi plus 24, take L square out. Now 24 plus pi, or I can write pi plus 24 divided by 4, and that's your answer. Or I can write 1 by 4 separate, then L square times pi plus 24 square units. Square units, and that's your answer. Kindly make a note. Now after that, let's have next question, question number 6. Question number 6 says, a medicine capsule is in the form of a cylinder with two hemispheres stuck to each of its ends. You have a medicine capsule which is of the shape of a cylinder. So medicine capsule like this. Let me bifurcate this. Medicine capsule in the shape of a cylinder like this, and two hemispheres are stuck to its ends. Just like this. Just like this. Now The length of the entire capsule is 14 millimeter. The length of the entire capsule is 14 millimeter. 14 millimeter is the length of the entire capsule. And the diameter of the capsule is 5 millimeter. The diameter is 5 millimeter. This is the diameter of the capsule. Find its surface area. You need to find the surface area of this capsule. Now what you are going to do, see, here, first of all, I can say one thing: diameter of capsule is equal to diameter of cylinder is equal to diameter of hemisphere, and that is equal to 5 millimeter. You got it? Which implies that radius of capsule will be equal to radius of cylinder, will be equal to radius of hemisphere, and that will be equal to 5 by 2, and that's 2.5 millimeter. After that, total height of capsule is 14 millimeter, which implies that height of cylinder. Now you know height of hemisphere is equal to radius of hemisphere. Now radius of hemisphere is 2.5. So height of cylinder from this point to this point, this is the height of cylinder. Height of cylinder is equal to total height minus this, or in other words you can say 14, that is total height of the capsule, minus this and this, so that is 2.5 plus 2.5. That will give you 14 minus 5, and that will give you 9 millimeter. Now 9 millimeter is the height of cylinder. Therefore, you need to find the total surface area. So total surface area of capsule is equal to, now total surface area of capsule means you need to, for example, you need to paint the whole capsule. Will you include the circular ends of cylinder? No. So curved surface area of cylinder plus curved surface of this hemisphere, curved surface area of this hemisphere. So I can say CSA of cylinder plus twice CSA of hemisphere. CSA of cylinder is 2 pi RH plus twice 2 pi R square. Now you know 2 times 2 pi R square. This curved surface area of hemisphere is 2 pi R square and radius is same, so I can take common 2 pi and I can take R common, so I'll get H plus 2R. H plus 2R. Now put the values in. 2 times 22 by 7 times radius. What is radius? 2.5. Then times height of cylinder. This H is height of cylinder, so height of cylinder is 9 plus 2 times 2.5 is radius. Got it? Now you can multiply 2.5 and 2 first, then you can add that result to 9, multiply the result to 2.5, multiply to 22, then to 2, divided by 7, and then you'll get 220 square meter. 220 square millimeter, and that's your answer. Now question number 7. A tent is in the shape of a cylinder surmounted by a conical top. A tent is in the shape of a cylinder surmounted by a conical top. So it goes like this. Conical top surmounted to a cylinder, or you can say cylinder surmounted by a conical top. If the height and diameter of the cylindrical part is 2.1 meter and 4 meter. So height is 2.1 meter. Height is 2.1 meter. 4 meter is diameter of the cylindrical part. 4 meter is diameter. And the slant height of the top is 2.8 meter. Slant height of the top is 2.8 meter. Like this. Find the area of the canvas used for making the tent. Find the area of the canvas used. That means the total surface area of tent will be the area of the canvas used to make this very tent. So you go like this here. Diameter of base is diameter of cylinder is diameter of cone, and it is equal to 4 meter. Which implies that radius of base is equal to radius of cylinder is equal to radius of cone is equal to 4 by 2, and that is equal to 2 meters. Then height of cylinder, that is equal to 2.1 meter. Then slant height of cone, it is equal to 2.8 meter. Got it? Therefore total surface area of tent. Total surface area of tent. Now total surface area of tent is equal to, because you will not consider this base because it's like this, tent without the base, tent like this, then like this. So this circle is not included, neither this circle is included. So you say total surface area of tent is equal to curved surface area of cylinder plus curved surface area of cone. Now curved surface area of cylinder is 2 pi r h, then plus curved surface area of cone is pi r l. Now pi r you can take out, then you write 2h plus l. Then pi you need to take, yes, you need to take 22 by 7 here, because in some questions it is mentioned that take pi is equal to 3.14. So usually you take 22 by 7 unless stated otherwise. 22 by 7 times radius is 2, then times 2 times height. Radius 22 by 7 is pi, r is 2, then this 2, then times height of the cylinder, that is 2.1, then times slant height of the cone, that is 2.8, like this. Then you can solve this. Sorry, here it's plus here. 2 times h plus l. Got it? Now first we'll multiply these two. Now 2.1 times 2, that is, so you got for this 42, so it's 4.2 plus 2.8, it is 7, 7 and 7 gets cancelled, that's 44. Now it's 44 square meter. 44 square meter, yes. Now 44 square meter is the total surface area of tent. Thus the required area of canvas, thus the required it says find the area of canvas used. Thus the required area of canvas used is 44 square meter. Now question says further, also find the cost of canvas. Now we need to find the cost of that canvas at the rate of rupees 500 per square meter. Now cost of canvas per square meter. Cost of canvas per square meter is rupees 500. Rupees 500. Therefore, cost for 44 square centimeter is equal to 44 times 500, and that will give you that is rupees 22,000. Rupees 22,000, and that will be your required answer. Therefore, cost for this square meter is rupees 24. Hence, the required cost. Hence, the required cost of canvas is rupees 22,000. And that's your answer. Make a note. Now, if you are not getting full chance to write it down or to make a note, then what you can do, you can pause the video, then you can make note easily. Now the next question number 8. It says from a solid cylinder whose height is 2.4 centimeter. From a solid cylinder. So you have a solid cylinder. From a solid cylinder whose height is 2.4 centimeter. Whose height is 2.4 centimeter. And diameter 1.4 centimeter. And diameter 1.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. A conical cavity is hollowed out. Just like this. This conical cavity is hollowed out from this cylinder, solid cylinder. Find the total surface area of the remaining solid to the nearest square centimeter. Now find this total surface area of this solid. Now again, it's like that one, cubical block, the hemispherical cavity is hollowed out. It's similar to that question. So what you can do, imagine a situation that you need to paint this kind of solid. It's cylinder, solid cylinder, and the conical cavity is hollowed out. Now you paint the curved surface area of the cylinder, the base of the cylinder, and you paint the curved surface area of the cone. Yes, so this top is not included. Now what I can do here, diameter of base is equal to diameter of cylinder is equal to diameter of cone, and that is equal to how much? 1.4 centimeter, which implies that radius of base is equal to radius of cylinder is equal to radius of cone is equal to 1.4 divided by 2, that is 0.7 centimeter, that is the radius. Then height of cylinder is equal to height of cone is equal to 2.4 centimeter. You got it? Okay. Therefore, total surface area of solid is equal to, as I said, you'll count curved surface area of this, or I can say curved surface area plus base, or I can say total surface area of the cylinder minus area of top, or curved surface area of cylinder, curved surface area of cylinder plus area of base plus curved surface area of cone. You got it? Curved surface area of cylinder, you are including this portion. Now area of base, you are including the base, and curved surface area of cone, you are including that conical cavity which is being hollowed out. Now curved surface area of cylinder is twice pi r h plus area of base is pi r square plus curved surface area of cone, it's pi r l. Pi r l. Am I right? Yes. Now here you get 2 pi r h plus pi r square, then plus, now radius is same throughout. Now pi l, I don't know the slant height of cone, I know height and radius of the cone, so I'll use h square plus r square under the radical. I can apply this. Now what I can take common, pi r and pi r. So take out pi r, now what's left? Twice h plus r plus h square plus r square.